Prepare to rethink everything you know about the origins of creativity. What if the magic behind a groundbreaking symphony, a breathtaking painting, or a poetic masterpiece traced its roots to the rigid world of mathematics? In Blueprints, How Mathematics Shapes Creativity, Marcus du Sautoy makes a daring claim that's bound to spark debate. The building blocks of both math and artistic expression grow from the same source: structures, patterns, and relationships that exist naturally in the world around us. Du Sautoy opens by painting a bold picture. Numbers stand alone in the universe, independent of human existence. Yet, from these solitary entities, mathematicians craft elaborate frameworks of unprecedented relationships. This process is deeply inventive, pushing mathematicians to discover entirely new understandings of reality. But here's where it gets controversial. Are mathematicians the only creative architects, or do artists engage in a similar form of structural invention? He argues that all artists, regardless of their medium, manipulate structures just as mathematicians do, even if they have no idea they're following mathematical rules. Take painters, for instance. Colors exist without human intervention. Yet painters instinctively observe how certain combinations create harmony or tension, a structure not unlike mathematical relationships. Writers craft poetry by arranging words within measured rhythms. And composers weave music by shaping connections between notes. Even in dance, bodies synchronize to form intricate patterns, all echoing mathematical blueprints. Du Sautoy boldly states, the structures that underpin human creation are always mathematical in nature. He supports this idea with dozens of lively anecdotes about collaborations with artists and creators who, perhaps unwittingly, gravitate toward the same concepts that fascinate mathematicians. One of the key ideas in Blueprints is the concept of mathematical blueprints, recurring patterns that form the invisible scaffolding of both mathematics and art. The book begins by exploring prime numbers, those indivisible integers so fundamental to mathematics that they are often called the atoms of arithmetic. Just as atoms assemble into molecules, every natural number greater than 1 is created by multiplying primes in unique ways. To show how prime numbers intersect with creativity, Du Sautoy tells a gripping story. Because these numbers are indivisible and do not align regularly, the musical patterns never neatly overlapped, dissolving the listener's sense of time passing. A perfect fit for a piece about the end of time. And this is the part most people miss. Mathematics doesn't just influence music at the surface level, like counting beats. It can go profoundly deeper, shaping the very way we experience a piece emotionally. Du Sautoy expands his argument by introducing a wide range of mathematical blueprints that appear again and again in both math and the arts. Circles, which he calls the atoms of geometry, Fibonacci numbers, the golden ratio, fractals, platonic solids, symmetry, hyperbolic geometry, and even randomness all find their way into the stories he shares. He links these blueprints to examples across cultures and artistic disciplines, from ancient mosaics to contemporary literature. For example, in literature, Du Sautoy discusses how Shakespeare's consistent use of iambic pentameter, 5 beats per line, using the prime number 5, creates rhythmic expectations in the audience. But whenever Shakespeare wanted to prompt surprise or highlight something magical, he would switch things up by using 3 or 7 beats instead, both primes. In Macbeth, for example, the witches speak in lines of 7 syllables, instantly setting their speech apart from the rest of the play and contributing an eerie undertone. But here's a detail worth debating. While du Sautoy credits the impact to prime numbers, is it really the primal magic of primes, or simply any change to the rhythm that would have a similar effect? The book swings back to music, pointing to Paul Desmond's famous 5-beat rhythm in the jazz classic Take 5, which the Dave Brubeck Quartet immortalized. Odd time signatures, like those with 7 or 11 beats, inject music with surprise, since our brains anticipate patterns based on even numbers. Du Sautoy illustrates how prime-based rhythms pop up everywhere, from the Beatles to the Allman Brothers and even in Radiohead's experimental tracks. He even recounts how the novel The Curious Incident of the Dog in the Nighttime numbers its chapters using only prime numbers, revealing a protagonist with a deep love for mathematics. This trick delighted readers and inspired some spirited debate over whether prime numbers are truly essential to the book's theme, or if it's just a clever device. Of course, not everyone is sold on du Sautoy's theory that all art is based on mathematical structure. Some cases, such as the use of primes in The Curious Incident, seem more like creative embellishments than absolute necessities. And when it comes to iambic pentameter, plenty of non-prime numbers shape the poetry just as much as prime ones do. Does this mean du Sautoy sometimes stretches his argument a bit? The book provides plenty of thought-provoking material for skeptics and enthusiasts alike. Despite its occasional leaps in logic, Blueprints is a joy for anyone even slightly interested in how mathematics collides with music, literature, and art. It offers a whirlwind tour through history's greatest thinkers, from Bach and Da Vinci to Fibonacci and Darwin, with a roster that is, admittedly, mostly European men. Should the book have highlighted a more diverse array of creators? Absolutely. But as du Sautoy himself might say, that too is a reflection of the structures of history. Importantly, you don't need advanced math skills to enjoy this book. A basic curiosity about the arts is enough. Du Sautoy's clear explanations and infectious enthusiasm help demystify complex ideas for beginners and experts alike. But now it's your turn. Do you believe that every act of creativity is built on hidden mathematical blueprints, or is that giving math too much credit? What patterns and structures do you notice in your favorite art, music, or writer? Join the conversation. Do you agree with du Sautoy's argument, or do you see creativity as something wilder, less bound by mathematical rules? Let's hear your thoughts. Blueprints: How Mathematics Shapes Creativity. By Marcus du Sautoy, published by Basic Books, ISBN 978-1541605695, hardcover 978-1541605701, ebook, publication date September 9th, 2025, 384 pages, $32 US, $42 Canadian.